Our sun will die. It's a cosmic inevitability, we know that. But what if that star's death isn't actually the final end for life here? What if it's, well, a surprising new beginning?
That's the really fascinating idea we're exploring.
Yeah, today we're doing a deep dive into white dwarfs, these like incredibly dense remnants of stars like our sun, and the case for life around them, which is, challenging but maybe really promising.
Absolutely. The article you shared, it really shifts the perspective, doesn't it, on where life could actually hang on or even start anew across the universe. It expands what we even mean by habitable.
Okay, so let's back up a bit. Our own sun's future. It's pretty dramatic. It swells up, becomes a red giant.
That's right. Huge, maybe 10, maybe even 100 times its current size.
Okay.
It'll definitely engulf Mercury, Venus, probably Earth, too.
Oh, wow. Okay.
And after that phase, after it sheds those outer layers, what's left behind is the core, the white dwarf.
Right.
So you've got about half the sun's mass, but it's crushed down into a space roughly the size of Earth.
Get this. An Earth-sized planet potentially orbiting an Earth-sized star. That's wild.
It really is. The scales are completely different from what we're used to.
So if a star dying leaves behind this unique little remnant, does that actually open up new chances for life, like real opportunities?
We think it absolutely could. For one thing, white dwarfs are super common.
Oh,
Estimates are around, what, 10 billion just in the Milky Way?
yeah,
And countless more are still going to form as other stars age.
10 billion.
Right.
Yeah, that's a huge number of potential places.
Exactly. So if planets orbiting these things can support life, it just massively broadens where we should be looking. It's just whole new eras and cosmic locations for life.
And there's recent research on this. You mentioned a paper.
Yeah, there was one just out, June 2025, I think, looking at a really key question. Could an ocean, liquid water, which we think life needs,
Right, essential.
could it even survive on a planet through all that red giant drama and then end up in the right place around the white dwarf?
Okay, so let's talk about that right place, the habitable zone. We know it for our sun, it's where Earth is, but for a white dwarf.
It's incredibly close because the white dwarf is so much fainter than the sun was. The Goldilocks zone for liquid water is maybe 10 to 100 times closer in.
Whoa, okay, that close. That sounds intense.
It is. And that extreme closeness brings its own major challenges, like tidal forces.
Ah, right, like Jupiter and its moons. Io is super volcanic because it's so close and gets squeezed by Jupiter's gravity.
Exactly that idea. Extreme tidal heating. But Europa, a bit further out, the heating is gentler, maybe enough to maintain that subsurface ocean everyone's excited about.
So a planet in a white dwarf's habitable zone would feel similar, really strong tides.
Very strong. Intense enough to potentially deform the planet, heat it up immensely, and basically boil off any surface water it might have had.
So how could a planet even keep its water?
But one idea is that the planet wouldn't have started there. To survive the red giant phase, it would need to have been much farther out initially, maybe Jupiter's distance, something like that.
Okay.
Then, after the star shrinks down to a white dwarf, the planet would somehow have to migrate inwards into that new, much closer habitable zone.
But wait, wouldn't that migration itself cause huge tidal forces and heating? Wouldn't that just boil the water off anyway?
See, that's the crucial part. It could, absolutely. But the timing might be everything.
Timing.
Yeah. If that inward migration happens relatively late in the white dwarf's life, after it's had billions of years to cool down considerably.
So it's fainter, cooler.
Exactly.
Right.
Then the tidal heating from the migration might be less severe. Maybe, just maybe, surface water could actually persist. It's a really delicate cosmic dance.
So have we actually found any planets like this? Earth-like, in a white dwarf habitable zone?
Not yet. The problem is white dwarfs are tiny.
Yeah.
So the usual way we find exoplanets, the transit method where a planet blocks the star's light.
It's much harder to spot that dip with such a small star.
Much harder, yeah. The signal is tiny, but there's hope with newer tools.
Like Webb, the James Webb Space Telescope.
Precisely. Webb might be able to do something different. Instead of just looking for the dip in light, it could analyze the starlight shining through a planet's atmosphere.
And look for, what? Signs of life.
Potentially, yes.
Yeah.
Look for molecules in the atmosphere biosignatures that wouldn't likely be there without life producing them. The white dwarf acts like a backlight.
Okay. That's pretty cool. A completely different way to search.
It gives us a new path forward, yeah.
So wrapping this up, what does this all mean for you listening? I guess it means a star dying isn't necessarily the absolute end. It could be maybe a really long-lasting new chapter.
It fundamentally expands how we think about habitable environments. Life might not just survive a star's death, it could potentially thrive for billions of years afterwards, long after we thought the story was over.
Billions of years
Mm.
around these faint, quiet, stellar embers. Imagine the kinds of life that might adapt to that. Civilizations in a kind of permanent cosmic twilight.
Mhm.
It really stretches the imagination, doesn't it, what the universe might hold.
It certainly does.
Something to think about. Until our next deep dive, keep exploring.